GATE CSE 2023. The output of a two-input multiplexer is connected back to one of its inputs. So here, according to the given figure, output of a 2-to-1 multiplexer is connected back to this input. I mean, the zero input. Match the functional equivalence of this circuit to one of the following options. 4 options are given. We need to match with one of the options. Now, if we study the operation of multiplexer, the operation itself tells us that when the select input is 0, this select input is 0, whichever data we apply at this particular input, that comes as output. According to the given figure, the Q output becomes data input for this particular diagram. So whenever I make select input as 0, the previous value of Q, it may be either 0 or 1, the same will be appearing as output. So it is something like our previous output appears as our present one. Suppose if the select input is 1, whichever data we apply here, it may be 0 or 1, the same appears as output here. So this behavior matches with DLatch. According to DLatch, when enable input is 0, the previous stored value of Q will be appearing as output. When the enable input is high, because active high enable, the data input what we apply, it may be 0 or 1, that appears as our output. So it matches with DLatch. Let us check with other options as well, because 3 more options are given. Let us match with other options. The first one is D flip-flop. If we go for implementing D flip-flop using 2-to-1 multiplexer, it needs double stages. 2 DLatches we need in order to implement a flip-flop. The first DLatch act as master, the second DLatch act as slave. Normally it is called master-slave flip-flop. Suppose if we apply clock input as 0, the complemented value of 0 becomes 1. Because we apply 1 here, whatever the data we apply, that appears here. However, at this situation, because the value is 1 here, this becomes 0. The 0, if I apply, the previous state of Q will be maintained. It is not going to accept output from the previous latch. When the clock changes from 0 to 1, when the input is 1, this value changes from 1 to 0, retaining the previous state. Previously, whichever D input you have applied, that will be retained. It is not going to accept any new data input. Under this situation, this state will be connected as here. Because this input is 0, complementing 0, it becomes 1. 1 means it accepts input from the previous stage. So whichever value we have applied during the low level of the clock input, that will be appearing at the high level of the same clock input. So we get the D input appear at the Q output during the positive edge. So this is called positive edge triggered flip-flop. The second option, half adder, is given. If you want to implement half adder, we know that it has 2 outputs, sum and carry outputs. So one AND gate is there. AND gate may be implemented using 1 2-to-1 multiplexer. Similarly, XOR gate is required to produce some output that is implemented by another 1 2-to multiplexer. In the given diagram, only single 2-to-1 multiplexer is shown, which may not be used to get the desired outputs. Both sum and carry output, it is not possible. Then the last option given here is demultiplexer. Comparing demultiplexer and multiplexer, very similar to multiplexer, only single select line is required for demux also. And also, if you compare the inputs, only single data input it takes. So here also only single data input externally we accept. However, for multiplexer, always we have single output, but for demultiplexer, we have more than one output. So this function does not implement demultiplexer also. The only option that the given structure or the diagram matches with is